In this video, I'm going to talk about stem and leaf plots. So a stem and leaf plot is kind of like a bar graph, but it uses data to display how tall the categories are. In other words, how many data values are in the category as opposed to rectangles. So as it kind of mentions here, it's a good choice when we're looking at data sets that are small. For the example, this class here, we have a bunch of exam scores. That's not a large amount of data. So this would be a good candidate for a stem and leaf plot. Now, to kind of go through these steps, it makes a little bit more sense to kind of step through this problem as we're doing it. What we're going to do is we're going to assign, because most of these numbers are two-digit numbers with the exception of the last one, which I'll deal with in a minute. We're going to assign one of the numbers to be a stem and the other to be a leaf. So I'm going to make every number in the tens place the stem, and then every number in the ones place is going to be the leaf. So I'm basically going to start with all of the numbers in the tens place, and that's going to form these numbers I'm going to write vertically. So I'm going to go ahead and draw a vertical line first. And that's a terrible vertical line. Let's fix that. Sorry. There we go. All right, and then the first number being 33 means I have a 3 in the tens place. The second little group of numbers start with 40s. So there'll be a 4 here, and then 5, 6, 7, 8, 9, and then the last number being 10. I'm going to extend that. There we go. That'll be 10 there. Okay, now every number has a ones place value like the 33. So I'll put a 3 here for the 33. For the 42, I'll put a 2. For the 49, I'm just going to put a 9. And the other 49, I'm just going to put a 9. So what you see I'm doing is I'm kind of putting the ones place on the right side. So when I see the 4, I know that's representing 40s. And I have one score of 42, one score of 49, and another score of 49. So for the next one, I'll have 53, 55, and 55. For the 60s, I have 61, 63, 67, 2 68s, and then 69 and 69. So what you can kind of see is I'm building like all of the numbers up next to the tens place that it's attached to. And what I'm seeing is kind of like a visualization. You can almost kind of visualize these as bars, right? The numbers are kind of representing bars for each category. So in the test scores that got in the 40s, I have 3 tests. Same with the 50s. But when I get to the 60s, I have twice as many exams who scored in the 60s. So let's move into the 70s. Let's see, we have 72, 3, 4, and 8. And then moving into the 80s, we have 0, 3, and then 3 eighths. And then into the 90s, let's see, 0, 2, 4 fours, a 6, and then the 100 we'll put here as the 0. Okay, so there you go. Now we have a kind of a visual display of the data. It's showing me that the bulk of the data is between 6 and 9, or in the 60s and the 90s. So most students scored between 60 and 90. I see that the highest categories are the 6 and the 9 themselves, right? People who scored in the 60s, people who scored in the 90s. Those two kind of represent the biggest categories. And it kind of gives me a way of looking at the data. I'm seeing how the class did overall. Overall, they did pretty darn well. I mean, yeah, I got some Fs, but because I see that so much of the data kind of occurs after this point, I can tell that overall the test went okay. And the people who studied, they got quite a few A's, right? We have quite a few A's in this data. So we're able to kind of examine it. The advantage of this is that we see the raw data in front of us as a visual display, which is why they do get used a lot in case studies with small amounts of data. It also gives me the opportunity to see an outlier. So if there's a data value that seems really different from the rest, I can see it very clearly on a stem and leaf plot and know what the data value is. So an example of that, like down here, this stem and leaf plot, clearly right? That's an outlier. And I know what that data value is. Now, real quick, I want to point out all of the data here is in decimal. So for this one, the stem was the number before the decimal, and the leaf was the number after the decimal. So they rounded every number to one decimal place, even something that didn't have a decimal, right? Like they wrote it as 4.0, one decimal place. Everything was rounded consistently. And sometimes the stem and the leaf are represented differently depending on what you're talking about. So often they include a key so you know what the data looks like. So they might say, okay, so when you see this number, in this example, it would mean 1.1. But in like our previous example, it would have meant 11 because I was looking at it as a tens place and a ones place. So it kind of varies from problem to problem how that's set up. Now, this next example wants us to do a side-by-side stem plot. So what that's going to look like is we'll have a stem plot on the right, going the way we've been drawing them. The leaves will go to the right, and then we'll also at the same time have one going to the left, leaves going onto the left side. So that's how we'll do a side-by-side plot. Now, this problem, unlike the first one, is not in order. The numbers are not placed in order. And the order does matter. I'm going to scroll back up and point that out, that we do want it in order from smallest to biggest. So see how it says, write the stems in vertical increasing order, rearrange the leaves in ascending order on step 3. So we want it to be in order. And therefore, this will be a great problem for me to kind of show you how you would go through that process. So real quick, I'm going to zoom out so I have some space here. And this problem is actually pretty substantial in terms of how many numbers are here. So they include 44 presidents on the left, so it wasn't including our last president, Trump. And then not every president has died yet. So there's actually only 39 presidents on the right that are listed because it's the age of their death. So inauguration on the left, death on the right. So we're going to start with the ones that have passed away, what their age is. And let's see, I'm going to kind of scan the data and I see 60s, 90s, 80s, 70s. I do see 40s. I see 40s for Garfield right here and Kennedy. Both of them are in the 40s. So, all right, that means then let me go ahead and I'm going to include 40s for this. So we'll have 4, 5, 6, 7, 8, and 9. Okay, now when I first do this, I'm going to cheat a little and we're just going to write all the data down and then we're going to reorder it. I find it a little bit easier that way. If I had space, I would do it both graphs underneath this. I don't have the space for it just because of my screen. So I would encourage you to do it two different ways, like do it out of order and then put it into order like how we're going to do. Okay, so let's see. For the first person, Washington, here I'm going to go ahead and take off those. Washington is 67, so I'm just going to throw 7 here in the 60s. Adams is 90. Jefferson, 83. Madison's 85. Monroe is 73. JQ Adams is 80. Now, notice it's not in order, right? I just threw a 0 there. That's fine. I'm just going to get them all listed, then I'll put them in order. Jackson, 78. Van Buren, 79. Harrison, 68. Tyler, 71. Polk, 53. Taylor, 65. Fillmore, 74. Pierce, 64. Buchanan, 77. Okay, there we go. So there's the first one. And here, I'm just going to take a quick count, make sure I got them all. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Uh-oh, I think I did miss one. 4, 5, 10. Oh, no, I did. Okay, 15. So I got them all. All right, Lincoln is 56. Johnson, 66. Grant, 63. Hayes, 70. Garfield, 49. Arthur, 56. Cleveland, 71. Harrison, 67. Cleveland again, 71. 2 Clevelands. McKinley, 58. Roosevelt, 60. Taft, 72. Wilson, 67. Harding, 57. Coolidge, 60. Hoover, 90. Roosevelt, 63. Truman, 88. Eisenhower, 78. Kennedy, 46. Johnson, 64. Nixon, 81. And then Ford and Reagan, 93. Okay, there we go. So I'm going to reorder this now, and here's how I'm going to do it. Just because of my space, I'm going to actually rewrite the 4s up here above. I'm going to go ahead and kind of extend that. I'm going to put a 4 here, and I'm going to rewrite it in order of 6 and 9, and then I'm going to erase my row. You do not have to do it this way. You could just rewrite this separately and give yourself a new stem plot to start with. Okay, so for the next one, the only thing that's not in order is the 7 and the 8. So 3, 6, 6, 7, 8. I'm going to be a little bit neater now too, now that I'm kind of doing my final one. Okay, for 6, let's see, we got 2 zeros. Looks like 2 3s, 2 4s, a 5, a 6, 3 7s, 1, 2, 3, and an 8. Okay, so I'm going to erase that. And I encourage you, if you want, pause your video, do it in order, and then compare to what I'm going to have. Okay, so for 7, we have a 0, 3 1s. Actually, here that 0 is kind of wonky. Let me line it up. Okay, 3 1s, 1, 2, 3. Then we have a 2, a 3, 4, no 5, 6, 7, 2 8s, and 1 9. And there we go. Okay, for 8, we've got 0, 1, 3, 5, and 8. And then last for 9, we have, that's already in order. Isn't that nice? Okay, so I'm going to erase that. And I'm going to go ahead and redraw this line so that it's the right height. Okay, now for the other side, and I'm not going to do all of it just because of time. I am going to show you the final answer. I would do the same thing, but I'm going to go the other direction. So I would start with Washington. So now I'm up here on the left one here. I'm going to start with Washington. And 57, I put it there. And then 61, 57 again, 57 again, 58, 57, 61, 54, and so forth. Okay. And then when I'm done, I'm going to reorder it, but it's going to go the reverse direction. So I'm actually going to have smaller numbers close to the stem and bigger numbers away from the stem. So it's going to kind of be like a mirror effect. So in fact, let me go ahead and show you the final answer because I wasn't able to fit it because there's so many in the 50s. That's what the final answer looks like. So you'll see that we kind of went in the reverse way. So for 50s, I mean, holy cow, the vast majority of our presidents were inaugurated in their 50s, some in their 40s, some in their 60s, and none beyond that. So we kind of get that picture of what it is in their age of inauguration. There's kind of like this 2-decade period where they tend to be president. And then for death, it really varies wildly. Now we know that some were assassinated prematurely, but yeah, that's kind of how we would look at a side-by-side stem plot.